Hello, I'm Mr. Atef and I teach math here, and I'm going to be going over a 5th grade problem. Okay, so here's the problem that I'll be going over. It says the ratio of cows to pigs is 7:3. If there are 32 more cows than pigs, how many pigs are there? So first of all, the students are going to be encouraged and sometimes required to draw a bar model. And so they're going to look at this ratio and they're going to first be able to understand the ratio. So they would know that the 7 represents the cows and the 3 represents the pigs. So from this ratio up here, they're going to be asked to draw a bar model to visualize that better. So when they're drawing their bar model, they're going to draw a cow bar, and that's going to include 7 units, and then they're going to have another bar for the pigs, which is going to be represented by 3 units. Okay? So then it says we got to piece the rest of the information into the problem. So it says if there are 32 more cows than pigs, how many pigs are there? So that second piece of information, they'll go ahead and they'll label on their bar model. So you can see that the bar model represents the problem above. The next step they would notice is that 4 units equals 32. So that's what they would write on their paper. They would say, okay, I can see from my bar model that 4 units equals 32. Then their next thing and they will know is, okay, I need to find out what 1 unit is because I'm almost getting to my answer. If I can figure out what 1 unit is, then I can figure out how many pigs are there because there's 3 of those units. So the next step they would determine is that 1 unit equals 8. And in 5th grade, I wouldn't require them to do the division because they would be able to know that if I divide 32 by 4, I will get 1 unit equals 8. So then to figure out the pigs, they would say, okay, well, what does 3 units equal? Because 3 units is basically the answer to my problem, and 3 units equals 24. So from this bar model, they'll be able to see that there are 24 pigs. So this is the power of using bar models like this to represent problems. It gives them like some tools underneath them to attack problems and to visually see what's going on in the problem. Okay, so they will definitely need that as they get into 6th grade. You'll see the next problem, how it jumps up a notch, and so they're going to have to really be able to draw bar models and piece information on the bar model to represent what's being asked of them. So the next problem is a 6th grade problem, and I'll go ahead and read it, and then I'll let you guys have at it for maybe for 3 or 4 minutes. Okay, so here's the problem. 88 children were in a swimming camp. 1/3 of the boys and 3/7 of the girls wore goggles. If 34 students wore goggles, how many girls wore goggles? Okay, so when I first started looking at problems like this, I thought, well, I can use a system of equations to solve this, and I wasn't sure how a 5th grader or how a 6th grader could do it. Okay, so I would encourage you guys to try to use what you observed throughout tonight to try to draw a bar model to represent the information that's given to you. Whatever you guys can gather from the word problem to put it into a bar model to make sense of it. So I'll give you guys about 3 minutes. Okay, time's up. Any answers? I'm just playing. There's a lot going on in this problem. And I did want to say something that I've actually seen a student's paper come back with algebra on it to solve it. And clearly it wasn't done by that student. I knew it was a parent, and I thought it was awesome. So anyways, I'm going to show you how this can be represented using bar models. and how clever the curriculum encourages the students to think. Okay, so I broke it down into 3 parts. I wrote a lot down, so it's mostly to just make sure that there's a clear understanding. So I'm going to go ahead and I'm going to try to explain this to you. So the first step is to create a model with the given information. Okay, so here's what the model would look like. So if you, 1/3 of the boys, okay, so 1/3 of the boys wore goggles. So here I have the boys labeled, and in my picture, I have 1/3 of the boys wearing goggles, okay? The other piece of information says that 3/7 of the girls wore goggles. So 3 out of the 7 wore goggles. And I even put the fractions there so that we can see that this is 3/7 and this is 1/3. Okay? Also, I purposely drew the boxes different because there's clearly a big difference between boys and girls. So the boxes are different. Yeah, that was kind of a joke, but it is important. But it is important that the boxes are different because they do represent different numbers, right? So, and we know that there's a total of 88 children. Okay, I don't know how it's distributed yet. And I do know that there are 34 students with goggles. So here I have 34 students who wear goggles. I can also find out that there are 54 students without. Okay, maybe some of you guys wrote that down on your paper. It's important to just write down as much information as you can gather from the problem. So here's my bar model. It's a good way for me to attack this problem, right? So a student can look at this problem. I bet you there are students in other schools that would look at this problem and just say, forget about it, right? But our students will hopefully be able to dissect the problem and then draw a representation using bar models to better understand it. So what else do we know or can gather from our model? So if I was presenting this to my students, or we were going through this, these are the questions that I would ask them, and we'd go through it. So this is the clever part, I think. So, we were told above that together, this 1 boy unit and the 3 girl units equals 34, right? Because 34 of them wore goggles. So what I can do is I can then group these together, similar as what was done earlier in the evening, right? And say that, okay, well, 1 boy and 3 girls, this chunk right here is 34 students, right? And then this other chunk right here is 34 students. So I've used up 68 students. So I can find out the difference. Whatever that difference is, I know that that's shared between 1 boy unit and 1 girl unit. So that's where I'm going next. So these remaining 2 units have to equal 20. Because if I take 88 and subtract out 68, I'm going to get 20 left over between these 2. Okay, so now I know that 1 boy unit plus 1 girl unit equals 20. So can we use the additional information to solve the problem? Okay, looking at this. So now I know that 1 boy unit and 1 girl unit equals 20. Okay, I'm not sure if you guys can see where I'm going, but it's almost the same strategy. I can then say, okay, well, this is 20, this is 20, this is 20. So now I have 4 units with whatever's left over. So I'm going to show you how I... So here, I've showed that now I know that this is 20, 20, and 20, so here we have 60 units. I'm going to, or not 60 units, 60 children. I'm going to subtract that from the total of 88, and then I'm going to see, so 4 girl units equals 88. Okay, so now we're going back, now we're going down into like 3rd grade, possibly even 2nd grade, right? So once we've gotten to this point, the kids are like they're ready to go, right? They can see it, they can taste it. And I'll explain this part right here. So here we have another simple bar model where we have 4 units. Again, these 4 units are here, right? Equals 28, which is the remainder, the 88 minus the 60. And here it's like the 5th grade problem where we have, okay, 4 units equals 28. I can divide that by 4 to get 1 unit is equal to 7. And then they know that 3 units equals 21 because they know what 1 unit is. Now, how did I get the 3 units? Because if you go back to the original bar model, you can see that we're asking for the 3 units there. How many girls wore goggles? Well, these are the ones. These are the 3 units. These are the ones that wore the goggles. So your answer is going to be 21 girls. So you can kind of see how clever it is for the students to arrive at an answer. Where before coming to this school, I would have thought, I'll teach it to an algebra, because this can be solved using substitution, systems of equations. Maybe you guys can remember doing that in college or high school even. So I hope you guys can. I even did it just to see. So this is what it might look like. You would define variables, let B equal the number of boys, let G equal the number of girls, and you say, okay, boys plus girls equals 88. 1/3 of the boys plus 3/7 of the girls equals 34. I'm not going to go too much into the details on this, but that way you guys can see that these problems actually can be solved with what they're learning in the Singapore math, and it does give them a great way to attack otherwise complicated problems.